Hi again. Now the second part, it is okay, the behavior of a resistor in an AC circuit. Then I'm gonna just really here talk about just I have a source and I have a resistor R, and I wanna maybe talk about how really this resistor is gonna behave in that circuit. Now, if I will assume the current to be I cosine omega t, and then actually I, it is the current amplitude, which means amplitude, which is the maximum again. Okay, and then I will say for VR, okay, VR, which is the potential difference at any moment, is going to be V cosine omega t. And I will say here again that V, we call it the potential difference amplitude. And we know that VR, which is the maximum, is going to be equals IR. And from that here, we know that at any moment, the instantaneous voltage and current are both proportional to cosine omega t. We call here, we say that current and voltage are in phase. And what does that mean? That means that if I have the voltage changing as this, let me draw this, okay? If this is V, here. If this is V and this is the current, I need to draw my points, it's easier. Okay, then the next one is here, 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 and the next one is here. Then this is how the current will show. Okay, which means when the voltage is maximum, current is maximum also. We call this in phase. All right, and therefore, I will say here that there is no lagging, there is no, I will say, what's the other word? Like they are moving together. Then the I will say the maximum with the maximum, the minimum with the maximum, with the minimum. Okay, then there is the same um, they are in phase. None of them is lagging behind the other. Now, when I have an inductor in the circuit, the situation is different. What's happening here is that instead of having a resistor, we have an inductor, and this is how we represent an inductor in the circuit, and we give it L. We are going to find that that inductor is now is going to have, let's say, the current in the circuit I cosine omega t. We are going that the induced EMF in the inductor will be opposing the initial current, and I will say this is gonna make here the voltage across it is gonna be V cosine omega plus phi, which means here that we have a phase angle phi, and I will say for a pure inductor that phi is 90, and we say that the voltage leads the current by 90, or we say the current lags by 90, or pi over 2 radians, or 1/4 of a cycle. Now, we will be able to define something called inductive reactance. It's very similar to having talking about resistance, and that it is XL equals omega times L, or like we can write it as XL 2 pi times the frequency times L. It has units of ohms. Also, we can write VL as I times XL. The VL, it is the potential difference across the inductor. Thank you, and I will